Alright, for this example problem, I chose a kind of an odd compound, xenon tetrachloride. Now, if you look at xenon, you're like, wait just a second, that is a noble gas. That can't be forming a compound. Well, some of the heavier noble gases actually you can force them into forming compounds. They tend to be high energy compounds, not last very long, but they're there. But we're just using this as an example for Lewis structure, so let's go ahead and go through our steps for drawing the Lewis structures. First off, valence electrons. Well, we go over here, we see xenon is, of course, a noble gas. It should have 8 valence electrons. Chlorine is right here. It's a halogen, has 7 valence electrons. So we go xenon, 8 times 1, chlorine is 7 times 4, right? Because there are 4 of them here. That should equal 28. This equals 30, equals 8. That should equal 36 valence electrons we need in our structure. Now, of course, the least electronegative element here is xenon. We're going to attach it to chlorines on the outside. Chlorine, 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 chlorine. All right, now let's put in our octets for our outer atoms. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and dot 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 dot. All right, here we go. Okay. Now, how many electrons did we actually use here? Well, if you look at this structure here, we have 8 electrons around each chlorine, right? Counting the ones bonded to xenon. So 8 times 4 is 32 electrons. We need to put in 36 electrons someplace. So we have actually 4 electrons we need to place somewhere. Well, remember the rule. If you have electrons left over after you've placed octets around all of the outer atoms and an octet around the central atom, you use an expanded octet. So we're going to put those last 4 electrons on that central atom. That is our Lewis structure for xenon tetrachloride.